Hi students, as a part of electrochemistry, to be more precise, as a part of a reference electrode, today I am going to explain you about one of the reference electrode. That reference electrode about which I am going to explain to you today is ion-selective electrode, which can be abbreviated as ISE, or it is also called as specific ion electrode, that is SIE. Now, as the name suggests, that is ion-selective electrode. Name is self-explanatory. As it is ion-selective electrode, it suggests that this particular electrode is selective to only one particular ion, which is along with the other ions in the solution. As it is selective only to one particular ion, which is along with the other ions present in the solution, this particular ion selective electrode acts as a sensor and senses only one particular ion from the solution, which is along with the other ions in the solution. And due to this, only one particular ion means one particular type of ions will move towards this particular ion selective electrode, and the activity or movement of these ions will be converted into potential. And what is another name for this particular ion selective electrode? So it is also called as specific ion electrode. So why it is also called as specific ion electrode? So this is called as specific ion electrode because this particular electrode is specific only to particular ions in the solution, which are along with other ions which are a part of the solution. That is, this particular ion selective electrode, that is specific ion electrode, act as a sensor and senses only one particular type of ion towards itself and converts their activity into the potential. So accordingly, we can define the ion selective electrode or specific ion electrode in this fashion. The electrode which acts as a sensor and converts the activity of one particular ion into potential is called ion selective electrode or specific ion electrode So in order to simplify the things, let me consider one example with you. So this is one of the ion selective electrode. Or specific ion electrode. And this is a solution which comprises so many ions like sodium ions are there, a part of it, chloride ions are there, a part of it, potassium ions are there, a part of it, and chloride ions are a part of it. Now, even though so many ions are a part of this particular solution, our ion selective electrode, this particular ion selective electrode or specific ion electrode is selective or specific only to the potassium ions. So since this particular ion selective electrode or specific ion electrode is specific or selective only to the potassium ion, what happens is this particular electrode, that is ion selective electrode or specific ion electrode, act as a sensor for these potassium ions, and senses only these potassium ions. And whenever this particular ion selective or specific ion electrode act as a sensor and senses only these particular potassium ions which are along with the sodium and the chloride ions, these potassium ions are moved towards this particular electrode. Only these potassium ions will move towards this particular electrode. Only potassium ions will move towards this particular electrode. So potassium ions. So only potassium ions are moving, leaving behind all the other sodium ions and the chloride ions. So let me show you. So see, only it is pulling the potassium ions towards itself, keeping the chloride ions and sodium ions intact. It is not pulling the sodium ions and the chloride ions. Sodium ions and the chloride ions are intact like that only. Only the potassium ions are moving towards this particular electrode. Why only the potassium ions are moving towards this particular electrode? This is because this particular electrode is the ion selective electrode or specific ion electrode, which is selective or specific only to the potassium ions. So that is the reason it is acting as a sensor and sensing only the potassium ions, because of which only the potassium ions are moving towards this particular ion selective electrode or specific ion electrode, leaving behind the sodium ions and the chloride ions intact. So what it is doing, students? What it is doing? It is pulling only one particular type of electrode, one particular type of ion, and during this, these ions are moving towards that particular electrode, and during their movement or during their activity, the potential is generated in the potentiometer. I hope you got it till now, right? Right. Now, let us discuss this particular ion selective electrode with the help of one example. That most popularly used ion selective electrode or specific ion electrode is the glass electrode, students. So glass electrode is the most popularly or widely used ion selective or specific ion electrode. Now we are going to discuss that particular glass electrode only. Right. Now, before going to discuss the construction and functioning of this particular glass electrode, we have to discuss, as it is a ion selective electrode or specific ion electrode, we have to discuss to which ions it is selective or specific. Because ion selective or specific ion electrode is the electrode which is selective or specific only to one particular type of ion. Now, as we are saying that the glass electrode is the ion selective or specific ion electrode, definitely we have to discuss what are the ions to which this particular glass electrode is selective or specific. This glass electrode, which is one of the ion selective electrode or specific ion electrode, is selective or specific only to the H plus ions. That is, it acts as a sensor and senses only the H plus ions from the solution, which is along with the other ions in the solution, and converts the activity of the H plus ions into potential. Now let us discuss what is the composition of the glass by which the glass electrode is made up of. The composition of the glass by which the glass electrode is made up of is, it comprises silica, 72% of silica, 22% of sodium oxide, and 6% of calcium oxide. So this is the composition of the glass by which the glass electrode has been prepared. Now this glass electrode with this particular composition have a low melting point and high electrical conductivity. Now we are going to discuss the construction and functioning of this particular glass electrode. Right. Now this is the glass electrode, students. This is the glass electrode. Right. And this glass electrode comprises a silver wire coated with the silver chloride, and internally we have a HCl solution, 0.1 molar HCl solution we have, and Why we are taking the HCl solution? Because we are well versed that this particular glass electrode, as it is the ion selective or specific ion electrode, it is selective or specific to H plus ions. That is the reason we are going to take the H plus ions containing the solution, and H plus ion containing solution is acidic solution. That is the reason we are considering the HCl, which is a strong acid, as the internal solution in the glass electrode. I hope you understood this. Right. So we are taking, and the most active part of this particular glass electrode is this bottom portion, students. This bottom portion, I will try to show this bottom portion. So this is the bottom portion, and this is the most active part. And this most active part, which is a part of the glass electrode, is called as glass bubble. So this is called as glass bubble, students. This is called as glass bubble. GLASS bubble, glass bubble. It is called as glass bubble. And why we are considering it as the active part or active portion of this glass electrode is it is thin. It is thin, and it is a portion which is selective or specific to the H plus ions, which are a part of internal solution inside the glass electrode. Now what it will do, it will pull the H plus ions, which are a part of the internal solution. It will pull the H plus ions towards itself. It will pull the H plus ion towards itself, because this particular glass electrode is ion selective or specific ion electrode, and it is selective or specific to the H plus ions. Now all the H plus ions will move towards this glass bubble, Now the concentration of H plus ions is increased on the surface of this glass bubble, which is the active portion or active part of this particular glass electrode. Now, if you see this particular glass bubble, so it has been enlarged in this particular figure. And this particular glass bubble is especially contains silica gel layers, and this glass bubble also contains 0.1 mm glass membrane with exchangeable sodium ions. Now, this particular glass membrane contains 0.1 mm glass membrane with exchangeable sodium ions. Means what? We can say that the glass bubble or glass electrode comprises the sodium ions, which are the cations, which are going to replace means that is H plus ions, which are a part of the internal solution replaces these Na plus ions, which are a part of the glass bubble. So the electrode reaction involved in this particular glass electrode is replacement of sodium ions of the glass electrode, which are a part of the active portion or active part of the glass electrode, which is the glass bubble, by the H plus ions, to which this particular specific ion or ion selective electrode, which is the glass electrode. All right. Now let us discuss how this particular electrode can be represented. This particular electrode can be represented in this following manner. Ag, silver chloride solid, which is the silver coated with silver chloride, and 0.1 molar HCl solution, which is the internal solution, and glass, and H plus unknown. So we are going to take the H plus unknown, means the solution whose concentration is unknown externally. So that I am going to discuss while determining the pH of the solution, making use of the glass electrode. What is that? And already have discussed. during this particular electrode reaction of this glass electrode, whatever the H plus ions which are a part of the internal solution, that is 0.1 molar HCl solution is present, those H plus ions replaces sodium ions of the glass bubble. Already I have discussed. The glass bubble is made up of 0.1 mm glass membrane with replaceable sodium ions. So H plus ions of the internal solution replaces Na plus ions of the most active portion, that is glass bubble. And do remember that the glass electrode is represented in the sense that is it can be formulated as Na plus Gi minus, and H plus ions will replace or displace sodium ions. Now, why the H plus ions are replacing or displacing only the sodium ions? Because do remember always that the cation will replace or displaces the cation, and anion will replace or displaces the anion. Now, H plus is cation or anion? H plus, right? So since it is a cation, it replaces or displaces only the cations. And what are the cations which are a part of the glass bubble? Sodium ions, that is Na plus ions. Now, on the reaction is this particular Na plus ions are replaced by H plus ions. Now, H plus ions takes the place of Na plus ions, and Gi minus will be intact like that only, and sodium ions are being eliminated out. Right. Now, coming to the last portion or last part of this particular ion selective electrode, to be more specific, glass electrode is the Nernst equation for the glass electrode. Nernst equation for the glass electrode is Eg equals to E naught G plus 0.059 pH. Now, by seeing this particular Nernst equation associated with the glass electrode, can you notice something? Yes, definitely. So pH is a part of it. So since the pH is a part of the Nernst equation associated with the glass electrode, definitely we can say that this glass electrode is used to determine the pH of the solution, because by rearranging the equation, we can get the information about the pH of the unknown solution. So do remember, students, this glass electrode is most popularly and widely used to determine the pH of the solution. So I hope you understood this particular glass electrode, ion selective electrode, and specific ion electrode. So based upon this, in the subsequent classes, I'm going to explain about determination of pH using glass electrode. I hope you understood, students. So thanks.